So back with me, Hanis, into the fourth experiment, which is frictional force. So the objective of this experiment is to determine the coefficient of static friction of different surfaces. So based on the theory, a body at rest or in equilibrium exhibit resultant force, or the sum of all forces acting on the body, is zero. Gravity is an attractive force that exists between two masses. The magnitude of the force depends on the magnitude of the masses. The gravitational force that acts on an object on Earth is approximated as Fg equal to mg, where m is the mass of the object and g is the gravitational acceleration. The magnitude of the gravitational force exerted on an object is referred to as weight. Normal force is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction, static and kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static frictional force is given by Fx maximum equal to mu Sn, where Us is the coefficient of static friction and N is the normal force. The coefficient of static friction is a dimensionless constant that depends on the object and the surface it is laying upon. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by Fk equal to mu Kn, where Us is the coefficient of kinetic friction and N is the normal force. So in this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured, and from the plotted data, the coefficient of static friction will be obtained.
For the apparatus, we use a wooden block, which is rubber covered at one side, and then 50 gram masses and 10 Newton spring scale, string and tabletop.
About the procedure of this experiment, first of all, measure the mass of the wooden block. Record and set up the apparatus as shown in figure 5.2. Make sure the tabletop is stable and horizontal to the ground. Attach the spring scale and the wooden block with a string. Place them horizontally on the tabletop. Make sure the rubber side of the block is faced downward. Place a M mass 50 gram on the wooden block. Pull the spring slowly. Once the blocks start to move, record the spring scale's reading. Record the value as Fs and tabulate in table 5.1. Repeat step 4 until 5 for 3 trays. Add another 50 gram mass on the wooden block and repeat step 5 to 6. Repeat steps until total of M 500 gram is on the wooden block. Repeat step 1 until 8. This time make sure the rubber side of the block facing upward. Tabulate the data in table 5.2.
For the result, first of all, we need to know the mass of wooden block with rubber surface, which is 0.082 plus minus 0.005 grams. First, we do the rubber surface towards the floor. We already convert the masses, which is from gram to kilograms. How to calculate the total mass? We just need to plus the mass of wooden block with the rubber surface and the masses that we use. After that, how to get the total weight? We just need to multiply with the gravity, which is 9.81. About the static friction force, we just need to do the 3 trial, and then we need to get the average, which is just plus the 3 trial and then divide by 3, so that we get the average. It's just the same with the non-rubber surface towards the floor. As we can see, the amount will keep increase after we put more the masses. That's what we get from the result for the two experiment, which is rubber surface towards the floor and non-rubber surface towards the floors.
So I'm going to present to you about frictional force, which is experiment 4. In this frictional force experiment, we got two kinds of surface, which is rubber surface and rubber surface. For the graph, we use static friction force for axis Y and normal force for axis X. For normal force, and you have to use average, and for the static friction force, which is axis Y, you have to use total weight. Okay, and after that, second step is you have to find the maximum point, minimum point, and the middle point. After that, after you completed find the maximum point, the minimum point, and the middle point, you have to find the gradient of phase speed. We use formula m equal to y2 minus y1 divided by x2 minus x1, and after that you record the answer. Next, you have to find the area of the middle point, which is you have to use formula 1/2 maximum point minus minimum point. After you got the answer. To find out coefficient or static friction, you have to use middle point plus the area of the middle point that we already find just now. Okay, and after that, m plus area middle, you got something plus minus with the area of the middle point. So that is how we calculate the analysis of this experiment.
So we move to the question. Number 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? So, anti-lock brakes stop a car in a shorter distance than regular brakes by engaging and releasing the brakes. The anti-lock brake system prevents wheel lockup and out of control skids. In braking situation, where the wheels on a non-anti-lock brake system equipped vehicle will lock up. Anti-lock brake system will generally provide shorter control stopping distance. Next, we move to question number 2. From your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? Non-rubber surface towards the floor has the highest coefficient. Yes, it is the smoother than surface, the higher the friction will be. The resistive force of friction determines the coefficient of static friction. Last one, number 3. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So, once the mass begins to slide, it moves, undergo stop and go motion because of friction. The velocity is decreased.
I will explain the discussion for frictional force experiment. Friction is an opposing force that prevents one surface from moving across another or attempting to move. Friction also is influenced by the weight and surface materials of the object. The heavier the block is, the larger the friction. It is assumed that the frictional force is proportional to the friction coefficient. These friction coefficients, a static friction coefficient and kinetic friction coefficient, are quoted for a specific pair of surfaces. The force needed to start an object moving from a position of rest is larger than the force needed to maintain that motion after it has begun. Therefore, static friction is greater than kinetic friction. That's all from the discussion.
In conclusion, students can determine by using a force probe to measure the static friction of a weight being put on a block of wood. When a wooden block was attached without any rubber and was pulled by a spring slowly, it creates law of static friction on table surface. Meanwhile, on the other side, a wooden block which was attached with rubber, it creates a high friction force compared to wooden block without rubber. Also, the table used to pull the weights on might not be completely smooth, causing the surface area to not be constant. So, the coefficient of static friction with rubber on greater than without rubber.